So we're moving on to question 8, the second of our context and applications questions. It's a 50-mark question. As soon as you see it, you say to yourself, okay, I know where we are here. We're doing trigonometry. The question says the pyramids of Giza in Egypt are over 4,500 years old. Fiona is laying down at point A, looking up at the top of the pyramid. She measures the angle of elevation to the top of the pyramid to be 15 degrees. She then walks 100 meters closer to the pyramid in a straight line and measures the angle of elevation while lying down to be 20 degrees. On the sketch above, draw a diagram showing all of her measurements. So I've been adding them in as we've gone there, so we can see that here is our point A. Here's our point A. 15-degree angle of elevation. She moves 100 meters closer. She now has a 20-degree angle of elevation, and that is a 10-mark question.
So this one's marked on a 0, 5, 10 scale, and it's a lovely, nice, easy one again to mark. So on this one, for low partial credit, we're looking for one correct measurement. So if you have the 15 degrees, the 20 degrees, or the 100 meters correctly marked in, that would be partial credit here for 5 marks. And then if you have all 3 correctly marked in, that would be full credit for 10 marks.
Okay, so, hopefully a relatively straightforward introduction to the question for you. So that's our part I. Part AII is calculate the height of the pyramid H correct to the nearest meter. So what can we say here? Well, as I often say to students, look, you're looking at this, you realize that what you're looking to calculate is your H over here. You might add that into the diagram. You mightn't be quite sure how to start thereafter, so you just fill in information into the diagram, which might help you to get to your final answer in the end. So if this angle here is 20, this other part is 160, together adding up to 180. Okay, what are we going to do from there? We can fill in, of course, this angle up here in the top to be 5 degrees, because the 160 plus the 15 plus the 5 gives us the 180. So what can we do? We're going to use the sine rule. And again, you mightn't be 100% sure where you're going with this, but you're just trying to use some information you have to work your way towards what you want, which is H at the end. So I'm going to try and find this angle here, or this side here, side A, using my triangle here, where I have 3 angles and I have 1 side. So let's have a look at it. I'm going to use my sine rule. I'm going to say A over the sine of 15 is equal to 100 over the sine of 5. Okay. All I need to do then is isolate A. I'm going to go at this stage, I'm going to put everything into the calculator. I'm going to get an answer of 296.96. And I know I'm nearly there, right? I have A to be 296.961550.6. I want to calculate the height of the pyramid. So what am I going to say in this next triangle? Let me just use a different color pen here. So in my right angle triangle, I now have the hypotenuse. I have my angle down here. So I can say, well, I know I'm looking for H, so that's the opposite. So I can say the sine of 20 degrees is the opposite over the hypotenuse. It's H over A. So it's H over 296.96. I multiply across and I get my final answer to be 101.566. I want it to the nearest meter, so that rounds to 102 meters. And that was a 10-mark question.
So this one's marked on a 0, 4, 8, 10 scale. So for low partial credit here, it's any work of merit in the right direction. So if you attempted to use the sine rule, that would be fine. If you substituted into SOHCAHTOA in some way, but you didn't have the correct value for A as it is in the PowerPoint, then that would be fine too. Okay, that would be a step in the right direction. So that would be for your 4 marks. For high partial credit, we're looking for A being found correctly, so finding the length of A correctly, and then an attempt to find the height. Okay, so an attempt to find the height. So if you just find Y correctly and then stop, that would actually be low partial credit here. You have to have an attempt to find the height to be able to get your full credit. It is a starred question, So that means incorrect rounding, you drop 1 mark. So you would drop down to 9 marks for incorrect rounding here.
Andrew, one thing struck me as I was doing the question, and you might say shed some light on it. Usually, we maintain our full answer here at this point all the way to the end, and I think that's what we did, wasn't it? But it's just for the presentation here of the PowerPoint, we shortened it down to 296.96 here. But
Yeah.
but if you maintain this full answer here with all the decimals, you end up with the same answer. That's correct, isn't it?
Absolutely. Yeah,
Yeah,
absolutely.
I think it was
Yeah.
just to make it a bit easier here on the presentation.
Yeah.
Okay, thanks very much. We're on to part B. Fiona draws a three-dimensional sketch of the pyramid as shown. She recognizes it as a square base with four triangular faces. The top of the pyramid is directly above the center of the base. She calculates the side of the base to be 230 meters. Find the distance along the ground from the center of the base to the vertices, writing your answer in third form. So there's quite a lot in that. Of course, we'd be saying to you, read it a couple of times, see, try and make sure you understand the logic of the question. We know there's a good chance you have done questions somewhat similar to this. So the approach that you generally find is you're going to get the diagonal of the square base. When we draw this right angle triangle with the diagonal, of course, we know all sides in the square are the same, so they're 230. We have a right angle here, and we know that the diagonals of a square bisect the angles, so this guy here is going to be half of 90, which is 45. Okay, what do? We're going to calculate D. Well, how can we do it? We could do it in a couple of different ways. We could use Pythagoras, or we can just say the cosine of 45 is the adjacent over the hypotenuse, 230 over D. Okay. All we have to do is isolate D. We want to get our answer in third form, so you just got to be careful with that. But it's 230 root 2. Okay, 230 root 2. That's for D. But of course, we're not finished because we read the question again. Okay, or we're just looking at, we could do it using Pythagoras' theorem as well, of course. But we got to be careful here. A lot of times you'll be sitting back now thinking, yep, job done. We move on. But of course, what we want is D over 2 because we only want half the length. So it's 115 root 2 meters. And that's a 10-mark question.
So on this one, we're marking on a 0, 4, 8, 10 scale again. So our low partial credit here for 4 marks is any work of merit in the right direction again. So if you substituted something into Pythagoras' theorem, or you substituted something into your use of SOHCAHTOA, that would count as low partial credit. High partial credit here for 8 marks is for any correct method but with one error in the calculation. So say you had forgotten to divide by 2 at the end, that would count as one error and therefore would be high partial credit for 8 marks. Similarly, if you had made a mistake on one bit of substitution and then continued to finish correctly, that would count as one mistake and therefore would be high partial credit. Note that on this question, it asks you to leave it in third form. This is a starred question, so if you didn't write it in third form and you wrote it as a decimal only, you would lose 1 mark, okay? And the decimal equivalent is 162.63. So if you only wrote it as a decimal, then you would lose 1 mark, okay? This question, you also need the units, so it's starred for that as well. If you have both of those mistakes, you drop down to high partial credit in this case. Okay, so if you are someone who wrote the answer as 162.63 without units, not in third form, that would be high partial credit because you have 2 mistakes on your star. Okay, when you just make sure, as Owen has said, you're reading the question properly. So when it says third form, you must leave it in third form. Note as well, if you write it in third form and write it as decimal, that's fine. That's absolutely fine. You can still have full marks for that. But it's just if it's only a decimal, it's starred.
And we know, Andrea, there's people out there that have just lost that 1 mark or possibly even down to high partial credit, and they're kicking themselves. Okay, part C. We're going to use our answer from part B to find the height L of the pyramid. So you got to be careful with the wording here because it's labeled as L in the diagram. Okay, so it's kind of like the edge of the pyramid, correct to the nearest meter. So We know, of course, that the height from the apex to the center of the base is 102. We know that from part A. From part B, we know that we have the 115 root 2. Because that's horizontal and the 102 is vertical, we obviously know we have a right angle triangle. And it's actually just Pythagoras from there to get your answer. And you get your answer to the nearest meter, and it's 192 meters is your length for L. And again, we have another 10-mark question.
So this one's also marked on a 0, 4, 8, 10 scale. So low partial credit here for 4 marks is Pythagoras used with some substitution. So as long as you have identified it's a Pythagoras question and you have made some substitution into that, that would be low partial credit. High partial credit would be 1 error. So if, for example, you had accidentally substituted in 115 instead of 115 root 2 for your value there that you need for the bottom of the triangle, that would count as 1 error. And if you then continue to finish, it would be high partial credit. It's a starred question again, both for rounding and for units. Okay, and just to reiterate, if you have one of those mistakes, it is starred and would be 9 marks. If you have both of those mistakes, in this case, it would go to high partial credit.
And Andrew possibly already said it, but just in case, if they had made a little bit of a mess of part B and just say they had a different answer, they had 105 instead of 115 root 2, were there follow through marks in this case?
Oh, absolutely, yeah. There would be follow-through marks. So if you had made mistakes on the previous 2 bits and you had correctly used them here, then you would get full marks here if you followed through correctly with your working, okay? So as we've said a number of times on these videos, if you make mistakes or you find something difficult, don't give up, okay? Even if you're using an incorrect answer, you could then use this question, which is Pythagoras. It's nice and straightforward because it's just use of Pythagoras. You could then use that correctly and get your full mark.
Okay, yeah, so again, that's part of the learning from this process. Show that corrected 2 significant figures, the total area of the 4 triangular faces in the pyramid, assuming they're smooth, flat surfaces, is 71,000 meters squared. So what are we going to do? Well, we're going to get one of the triangular faces. Of course, we now know that this length here that we said was L. L was equal to 192. We have our base length of 230. There's a couple of different ways of doing this. You can get H in this case, which is actually the slant height of the pyramid. You can use Pythagoras' theorem for that. Obviously, the full length was 230, so half of that is 115. Using Pythagoras' theorem, we're going to get H is equal to 153.7, okay, meters. And then we can find that we know to find the area of this triangle. Well, there's 4 of them. We know there are 4 triangles. So what are we going to be using here? We're going to be using half the base by the perpendicular height. So yeah, okay, that's fine. Yeah, half the base is a 115. The perpendicular height is a 153.7. Of course, there are 4 triangles. So when we multiply all that together, we get 70,702, and to 2 significant figures is 71,000 meters squared. And again, another 10-mark question.
So this one is marked on a 0, 4, 6, 10 scale. So low partial credit here is work of merit to find the perpendicular height. So if you would use Pythagoras and substitute it in, that would count as work of merit for the perpendicular height for 4 marks. Mid partial credit in this one. Oh, sorry, I said the scale wrong. It's 0, 4, 6, 8, 10. Sorry. So mid partial credit here, which is 6 marks, would be work of merit to find the area of one of the triangles. So if you used your half the base times the height and you substituted in some of your numbers into that, that would be work of merit to find the area of one triangle. And then high partial credit would be that you had you had used your area of your triangle and multiplied it by 4. So taking your area that you found for a single triangle and multiplying through by 4 would be high partial credit here. But for some reason you have finished incorrectly. This is a starred question, so it's starred for both units and rounding. Okay, so starred for both units and rounding. So 9 marks available if you got one or the other of those wrong.
Okay, That's great. And so we're actually finished with that question now. So that's the end. That part D was the end of that question, 71,000 meters squared. Hopefully that was a relatively good question for people. If you've done a good bit of trigonometry in the course in your school, of course you've seen something similar to this before. Okay, let's move on to our final question, question 9.